Day 0 notes is on simplifying rational functions. First, we're going to look at a few definitions. The first definition is polynomial. Polynomial comes from poly, which means many, and nomial, which means term. So essentially it means many terms. So here's an example. A term is things that are separated by a plus or minus. So in this first polynomial, we have three terms. One is 4xy squared, and one is 3x, and one is negative 5. Notice terms are separated by pluses or minuses. All right. In a polynomial, so something has many terms, you can have constants, numbers, you can have variables like x and y, and you can have exponents like y squared, y to the third power, y to the first power, y to the 0, but you can't have exponents that are fractional. You can only have whole number exponents. There are special names for polynomials with 1, 2, or 3 terms. So one term means it has one thing, no plus or minus, separating two terms. So one term is called a monomial. Two terms, and we've been looking at these or studying these earlier this year, two terms is called a binomial. And three terms, so three things separated by a plus or minus, is called a trinomial. How do you remember the names? You can think of cycles. Like a unicycle is also called a monocycle, and that means one wheel. A bicycle has two wheels, so a binomial, two terms. A tricycle has three wheels. A trinomial has three terms, three things separated by pluses or minuses. All right, so there's our first term, polynomial. So something that has many terms. And so tomorrow on day 1, we'll also look at this definition again. The second definition for today is a rational function. A rational function is a ratio of two polynomials. So a ratio means it can be written as a fraction. So here are 3 examples of rational functions, things that can be written as a fraction. So you have 9 over 3, which we know that reduces to 3 over 1. That's a ratio. It's written as a fraction, so it's called a rational function. We can add in letters here, so we have 4xy to the 7th over 12x squared y to the 3rd. Notice we can have coefficients. We can have those numbers in front, like 4 and 12. We can have variables like x and y, and we can have exponents that are positive whole numbers. Okay, let's take a look at another ratio. This is a binomial, 2 terms, divided by a trinomial, 3 terms. And this is a rational function because it's a ratio or a comparison of two things, or it's written as a fraction. Okay, so these are all examples of rational functions. And our goal today is to simplify these rational functions. Okay, so we're going to start with simplifying monomials, which is one term over one term. And this is actually a review of something that we did in first semester, the Chapter 5 Exponents chapter. We did simplify monomials, things with exponents. All right, so when we did this first semester, we took a look first at the coefficients. We have 8 and 24, and we talked about how can we reduce that? What's the biggest number we can divide 8 and 24 by? And the answer is 8. We can divide each by 8. So 8 divided by 8 is 1. On the top, 24 divided by 8 is 3. So when we reduce 8 over 24, that is the reduced fraction 1/3. The second thing that we looked at was the base. Things that have the same bases, we can reduce. So we have x to the 4th power over x to the 1st power. So essentially it's saying you have 4 x's on top, you have 1 x on bottom. When you cancel, how many are left and where are they? And so here you would have x to the 3rd power on top. Another way to write this, you don't need to write the 1 there, so we could also write this as x to the 3rd over 3. And that is a simplified rational function, a monomial over a monomial. All right, let's do another example. Again, we'll start with the coefficients. We look at the 20 and the 15 and we think, can we reduce that? Is there a number we can divide 20 and 15 by? And the biggest number is 5. So let's divide each by 5. 20 divided by 5 is 4. 15 divided by 5 is 3. So we get 4/3 as our reduced fraction. Now let's take a look at the same bases and their exponents. If you have 7 x's on the top of your fraction and 11 on the bottom, when you cancel, how many are left and where are they? And so when we cancel, we would cancel 7 from top and bottom, and we would have 4 left on the bottom. So we would say x to the 4th. And there is our simplified rational function. Let's try one more. All right, we have 24 over 22, x squared over x squared. Okay, so again, let's look at just our numbers right there, the coefficients. And you want to think, what's the biggest number we can divide 24 and 22 by? And the answer is 2. So 24 divided by 2 is 12. 22 divided by 2 is 11. And then we have x squared divided by x squared. And when you cancel, how many x's are left? And where are they? And here, it would just cancel, and you would have just a 1 left, right? X squared divided by x squared is 1. So our final answer is 12 over 11. And I didn't do any examples with other letters, so I'm just going to make one up. Let's just do 6/3 xy to the 5th over x to the 10th y to the... I'll just do y. Okay, so here will be our last example of a monomial over a monomial. So again, we'll start with our 6 divided by 3. What is 6 divided by 3? That's 2 over 1, or we can just write the 2. When we look at our x's, we have 1 x on the top and 10 on the bottom. So when you simplify, how many are left and where are they? And there would be 9 left on the bottom. And then when you have your y's, you have 5 on top and 1 on the bottom. So when you reduce, how many are left and where? And you would have 4 left on the top. So our final answer, reduced rational function, is 2y to the 4th over x to the 9th. So again, this should be a review. You did this in chapter 5, a monomial over a monomial, but now we're looking at simplifying rational functions, and so this fits under that category as well. Okay, so let's take a look at what if they have a binomial or a trinomial. How would you simplify that? And so there's basically 3 steps. Number 1, if you can, you want to factor anything out. Number 2, you want to reduce the factor. And number 3, you want to rewrite in simplified form. So I just pulled a bunch of examples here, 5, and then your assignment will be to practice more of these and also the monomials. Okay, so the first one is a monomial over a binomial. So again, mono 1 term over binomial 2 terms. Okay, so the first step is to factor out anything that you can. And so the 6x, we'll just leave it. Can't really simplify that any further. But on the bottom, we have x to the 3rd and 7x squared. So you want to think, what's the greatest common factor? What can I pull out of each of those terms? And each of those have an x squared that you could divide out. So I'm going to pull out the x squared, and I'm going to divide each of these by an x squared and write what's left over inside the parentheses. So here, x cubed divided by x squared. How many x's are left? There's 1x left. And then we have 7x squared divided by x squared, and the x's cancel, so you have 7. So basically, we're undoing the distributive property. If you want to check your answers, if I multiply these out, we get what we started with. Okay, so we are factoring now. We're pulling out the greatest common factor. So let me undo that. Okay, so I'm going to rewrite that, and I have 6x over x squared times x plus 7. Okay, another way to write that, x squared, that is x times x. Okay, so now we look at everything that's being multiplied. We have a 6 times an x on the top, and on the bottom we have an x times an x plus 7, and we want to think, can I reduce anything? And you can. One of these x's that's being multiplied, you can divide by one of these other x's that is being multiplied. So we're going to simplify that. X divided by x is 1, and so that cancels. And our final answer is 6 over x times x plus 7. So there's an example of pulling out a greatest common factor, and then taking a look, what's the same on the top and bottom that we can cross off? And there was 1x on top that we could cross off with 1x on the bottom. All right, let's try the next example here, which is a trinomial over a binomial. Let's factor this. So I'm going to do the top part in red. This one is an x squared. There's 3 terms, so this is the guess and check one, or box and circle. Since it's just 1x squared, I'll use guess and check. This is what multiplies to negative 12 that adds to positive 4. And so if you play around with that, what multiplies to negative 12 that adds to positive 4, that would be a positive 6 and a negative 2. So if you multiply those together, they multiply to negative 12, they add to positive 4. So there's the top factor. The bottom I'll do in blue. X squared minus 4, that's difference of squares. 2 square numbers being subtracted, that's when you write x plus and x minus, and the square root of 4 is 2. Okay, now we look at everything that's being multiplied. So again, in this example, we took a look at the 6 times the x times the x times the x plus 7. We looked at everything that's being multiplied, and we want to cross off things that are the same. And so if you look, an x minus 2 and an x minus 2, those are the factors that are exactly the same. They would cancel. And so our final answer would be the x plus 6 over x plus 2. Notice we cannot cross off these x's. And you might argue, well, there's an x on top and an x on bottom. Why can't you cancel them? And it's because they're being added and not multiplied. So if you took a look at the ones that we canceled here, these were being, multiplied. And so we could cancel them. And this one right here, they're being added and we can't. Here's an illustration of why you can't just cancel them. I'm just going to pick a number for x. I'm going to say, what if x is 1? Let's plug in. So that'd be 1 plus 6 over 1 plus 2. All right, let's say we solve this. On the top of the fraction, you'd get 7 plus 1, or 6 plus 1, which is 7. On the bottom, 2 plus 1, which is 3. So this equals 7/3. But let's say you wanted to cancel the 1s. That would be 6 over 2, which is 3. And 3 is definitely not the same as 7 over 3. So that's why we can't just cancel the 1s if they're being, or the x's if they're being added. You can only do it if it's being multiplied. Okay? Another example of when they're being multiplied. Let's say we had 6x over 2x. We could cancel the x's. And the reason is, let's say x is, 2. 6 times 2 over 2 times 2 is 12 over 4, which reduces to 3. And if we just cancel the 2's, 6 divided by 2 is 3. So if things are being separated by a times, you can cancel them, but by a plus or minus, you cannot. So our final answer is x plus 6 and x plus 2. All right, let's try a trinomial, 3 terms, divided by a trinomial, 3 terms. Both of these we can do guess and check because they both start with an x squared. So the top one is what multiplies to 90 that adds, multiplies to negative 90 that adds to negative 1. And so if we think about it, it ends up being 10 and 9, and we want it to add to a negative 1, so we have to make the 10 negative. So negative 10 and 9, they multiply to negative 90, and they add to negative 1. All right, so there's the top. The bottom is what multiplies to 70 that adds to negative 17. All right, so in this case, it would be 10 and 7 multiplied to 70, but we have to make them both negative, so they add to negative 17. All right, so there's the first part, factor. Now we're done. The second part is cancel or reduce the common factor. Okay, so the common factor, what can we reduce here? Well, we see the x minus 10 as being multiplied to each of these, so we can cancel that. And our final answer is the x plus 9 over x minus 7. You can write with or without the parentheses. All right, so that's our whole goal today. And as we move forward is, can we simplify these? All right, the next one, a binomial divided by a binomial. So the top right here is difference of squares. That would be x plus and x minus, and then the square root of 36 is 6. So difference of squares when you have two square numbers being subtracted. The bottom, if you take a look at it, we can factor things out. What's the biggest number we can divide 4 and 36 by? I'm going to do that over here. So we have 4x squared minus 36x. We can divide each by a 4, and we have an x squared and an x, so that means we can divide an x, at least an x out of each of them. So when we divide it out, we think, okay, what is 4x squared divided by 4x? What's left? There's an x left, minus, what is 36x divided by 4x? And that would be 9. And so there we factored out the 4x. If you want to check your answer, you can distribute, and we should get what we started with. Okay, so there's the bottom factored. We have 4x, and we have x minus 9. All right, so if we take a look at that, is there anything that we can factor out of this right here? Simplify, and all the factors are different. So this is our final answer. Okay, and our last one, the top, we have a binomial divided by a trinomial. So the top, we want to think, all right, what's the greatest common factor of x squared and x? And we can divide each of those by an x. So x squared divided by x, there's an x left. X divided by an x is a 1. So there's the top, we pull out the x. The bottom is what multiplies to 8 that adds to 9. And so we'll put x, and let's see what multiplies to 8. That would be 8 and 1. And if we make them both positive, they add to 9. Okay, now we look for things that we can cancel, and they both have an x plus 1 that's being multiplied. So there's that common factor we'll pull out, and our final answer is x over x plus 8. Notice you cannot cross out the x's because there's that plus there between the x and the 8. So here's our final answer. Okay, so there's a lot of factoring, as you can see. So if you have trouble with the factoring, remember we did this in Chapter 7, Part 1. So if you have trouble with factoring, we'll go to Chapter 7, Part 1. I think what I'll do is on the Google Classroom assignment, I will put a link to those YouTube videos, the factoring YouTube videos, and just watch those if you feel like you need the extra review. Many of you are very good at factoring and you wouldn't need to watch those again, but I will attach those in case you need help with the factoring, because you'll have to be pretty good at factoring in this unit. As you can see, we've factored quite a bit today. All right, so our assignment today is on Delta Math. And so if you don't have an account, what you're going to do is you're going to go to deltamath.com, and you can go there and create an account. Put your name in there. You might want to use your Google Apps account and put your name so I can see that you did it. You'll have to look up my teacher code. It's 125719, and I'll have some assignments listed there. And here's the one that you want to complete, the Day 0 Simplifying Rational Functions Daily Practice. The assignment is 9 questions long, so 9 of these. All right, so we did 5 of them together, and I actually pulled these from Delta Math, so you might see them again, but they might be mixed up or they might be different. The assignment is 9 questions long, though if you make a mistake, it will show you the steps on how to do it, and it will have you try another one. So 9 questions long. Some people like to do it and do more than 9 questions, and that's fine, but you have to get through the 9 questions. And again, the reason why I like Delta Math is it does show you how to get the answer if you have trouble. So do that, and then you'll get the points when you complete the Delta Math assignment.